Today we're going to talk about Chapter 5, Repetition Structures. Here are the chapter topics. You can read over them when you're reading the chapter. Introduction to repetition structure. A repetition structure causes a statement or a set of statements to be executed repeatedly. What that means is if you're going to execute the same code multiple times, you'd put it in a repetition structure. It allows a programmer to avoid duplicate code. Duplicate code makes a program much larger. So if I was going to run the same code 50 times, instead of having it in there 50 times, I'd put it in there one time in a repetition structure. Write a long sequence statement is time consuming. If part of the duplicate code has to be corrected or changed, then the change has to be done many times. Condition controlled loops. You have the while loop, the do while loop, the do until loop. The while loop runs the loop while the condition is true. The do while, it will run the loop until the condition is true. The do until, it would run the loop until the condition is false or until it's true. With all loops, be careful not to create an infinite loop. Always provide a breakout. What that means is if you're not giving it, like if you're saying do it 20 times and you're not adding one to a counter and keeping up with the number of times, you have an infinite loop. Here's an example of a while loop. You have the while and then the condition, and you have a statement or multiple statements, then you have the end while. So what would happen, you'd say while count is less than or equal to 10. You'd run this, and somewhere in one of the statements would be you'd add one to count, and then it would do it 10 times. But once this condition evaluates to true, it goes to the end while and doesn't execute anymore. This is called a pretest loop because you're testing the condition before you go into the loop. So on a while loop, you may or may not execute the statements inside the loop. Work with modules and loops. If you want to run the module multiple times, you can just put it inside a loop. Let's look at this flow chart. You have this is the control variable called keep going. They initialize it to y. This is where they're testing the condition. As long as this condition is y, it'll keep doing this loop. It'll go here, go back up here, ask again, and on and on. Notice down here, they're giving the user a chance to change the control variable. This is what causes the infinite loop. If you don't allow them to change the control variable inside the loop, it's always going to equal y, and you'll be in an infinite loop, which means that your program just goes on and on and on until you do Control-Alt-Delete or till it ties up all your resources. You have to reboot the system and everything. So make sure when you're doing a loop, you give it a chance to change the control variable to come out of it. Do while loop is a post test. Notice down here, they're going into the loop and then they're not going to test it to at the end. So that means it's going to execute the loop at least one time. A while loop may or may not execute it. A do while will definitely execute it one time. Kind of similar to the previous example. The only thing they don't initialize it to y because it's going to do it one time anyway, and then the user's going to enter it in again. If it's y, it's going to go back and keep doing it. You say, well, how do I know when to use a pre-test and a post-test? If you want to execute the loop at least one time, then you can do a do while. If you don't, you can do a while. The only time I did it in industry was like when I was writing a maintenance program or some kind of program to where a user enters in information and I have to test every field to make sure it's valid information. You know you want to do it at least one time, so that's when I used to do while. Do until. Loop iterates until a condition is true, but not all languages support this. It works similar to the do while right here. It's going to do it one time. Look at the do until. It's going to do it all the statements and then test it. So they work similar. A count control loop iterates a specific number of times. This is talking about a for loop is best used for this situation. So if I know I'm going to execute it 10 times, do it in a for loop, not a do while or a do until or a while. Always use a for loop. Why? Because it gives you some advantages. Inside the loop, you do the initialization, you do the testing, which is the condition, and you also do the increment. So you don't have to worry about forgetting to initialize it before the loop or forgetting to add one to it inside the loop. You do that all in the for statement. So they're declaring the variable and then declaring a constant. Set counter less than or equal max value, and they add one to it. See, you can tell right there, that's not a for loop. That is a while loop. You say, how do I know it's a while loop? Because they're testing before they're executing the loop. For loops can also increment more than one, count backwards by decrementing, or allow the user to control the number of iterations. General loop concerns. Do not forget to initialize the loop control variable. Do not forget to modify the loop control variable. Many loops are interchangeable, but generally use a while loop when the loop may not have to process. Use do while when it must process at least once. Use for when the specific number of iterations. That's just a rule of thumb, period. It's very good. So if you don't remember anything about these loops, remember that. If it may not have to process, use a while loop. If it must process at least once, do while. Do until would do the same thing, but some languages don't support that. Use a for loop with a specific number of iterations. All right, here's an example of a running total A running total is the sum of a number that calculates with the iteration of a loop. So let's go over this. You have a integer number, integer total equals, they're initializing it, integer counter. This program calculates the total of 5 numbers. It's setting counter to 1, and it says why counter is less than or equal to. So the first time through it's going to say enter a number. They say input number. And then they're adding to the accumulator. This is called an accumulator. And then they adding one to the counter. So it's going to do the first number, whatever the user entered is. Say if I enter in a 10, total is going to be a 10. It's going to go back up here. It's still less than 5 because the counter's 2 at this point. It's going to say enter a number. It's going to input the second number. If I do 5, it's going to add 5 to it. Now the total will be 15, and it does that 5 times. Here's one thing I want to point out. You want to be user-friendly to the user. What I mean by that is tell them what number they're entering. Say enter number space 1. And you do that by using the concatenation feature. You say enter number space, and then you concatenate that with a variable counter. So if you don't do that, I'm going to count off. I'm in my office and I get a phone call, and or somebody comes in my office. I have no idea what number I'm entering at that point. I have to stop and answer it. So you always tell the user, hey, you're entering in number 1, you're entering number 2, or whatever. And you do that again by using the concatenation feature. Sentinels. A sentinel is a special value that marks the end of a list of values. They are used as stop values for loops. How can it be done? You ask the user at the end of each loop iteration if there's another value to process. You ask the user at the beginning of the loop how many times the loops are processed. Here's an example of a nested loop. You declare integer hours, minutes, and seconds. You set hours equals 0. If hours is less than or equal to 23. You say, well, how come it's not 24? Because remember, military time, hours start at 0. That's why they did 0. So it's at 0, so it's going to go right off here to true, and it's going to set minutes to 0. And said if minutes is less than or equal to 59. You say, how come not 60? Because when it goes up to 60, it's going to the next hour. And so it's going to go in here. It's going to be true. It's going to say seconds equals 0. And seconds less than 59, so it's going to go here. It's going to display the hours, the minutes, and the second. So the first time it's going to hit it, it's going to be 0 hours, 0 minutes, and 0 seconds. And it's going to add 1 to it, go right back up here. And it's going to be 1 second, 2 seconds. When it gets to 59 seconds, it's going to come out there here, add 1 to minutes, and go back up here and be 1 minute. And then that's just the way it keeps going. So now let's look at the lab sheet. This is lab sheet 1. This is kind of similar to chapter 4. You're going to have 2 different lab sheets, 2 different programs to turn in. So what you do, you fill this in. And what this is saying is, in step 2, in the space provided, create a loop control variable, keep going, of the data type string. Initialize this to y. So that's what you do right here. Declare string keep going equals y with quotes. All right, then you have to fill the rest of this in. You say, well, what's going to be the control variable? And what do I check? What do I do this loop? Well, while keep going is equal to y. And then where are they inputting to change it? So you just go through and fill all this out, and it tells you, and a lot of students get a little confused, but it tells you A is the missing parameter list. So that tells you what goes in A, it tells you what goes in B, and so on. This up here, step 3 and so on, you may or may not use all these lines. So don't think you have to fill in all of them. You just put what it needs. And then when you get down here to lab, the lab you're going to do is sum of numbers. It says design a program with a loop that asks the user to enter a series of positive numbers. The user should enter a negative number to signal the end of the series. After all the positive numbers have been entered, the program should display their sum. And it even gives you a hint. Use the while loop. Now when you're displaying the sum at the end, you don't just put the number. You got to tell the user what that number is. Sum equals, or the sum is, or whatever. But they haven't given you an example of what the control variable is on the loop. You say, how do I know? I'm going to do it to a y. Do you want to continue? No, it says until they enter a negative number. So what condition would you test to make sure it's a negative number? That's the hardest thing you got to figure out. The rest of it is pretty much, they gave you an example in the book on this PowerPoint. We just went over about how to add up an accumulator. So when you get done with this lab sheet and that one lab that is named CH5 Lab 1, I'm going to start counting off. I've been real lenient, but I've told y'all multiple times now. Make sure you name this program CH5 Lab 1. Then you zip both of those files, the lab sheet and this program, into a compressed zip folder called your last name and CH51. And then submit that on Blackboard. Now let's go to Lab 2. It's kind of similar to Lab 1, except you're going to fill out different things. Right here it says explain what you think will be displayed on the screen 1. So you look at all this and you write what you think would be displayed. Now I'm going to help you on this one. It says constant integer max hours equals 24. Declare integer hours. For hours 1 to max hours. This is a for loop that it didn't show you how to do on that PowerPoint. Not sure why it didn't give an example. But this is the hours equals 1, so that's initialization. The 2 max is 2 max hours, that's the control loop. And it's not incrementing because by default a for loop increments by 1 if you don't put the step in there. If you want to increment by 2, you'd say step 2. And then what's going to display inside this loop, the hour is space and then whatever the hour is. So if you go look up here, you're starting at 1. So what's going to display is the hour is space 1. Then it's going to hit this N4, go back up here again, and the hour, it adds 1 to it, so the hour at this point is going to be 2. So it's going to say the hour is 2, and it's going to go all the way up to the hour is 24. That's what's going to be the answer to step 2. So you follow the same process for all these. Fill all those in. When you get down here, you got a bug collector program. A bug collector collects bugs every day for 7 days. Design a program that keeps a running total of the number of bugs collected during the 7 days. The loop should ask for the number of bugs collected for each day, and when the loop is finished, the program should display the total number of bugs collected. It's very similar to the previous lab you did in chapter 5.1. Only difference there, you was keeping up with a sum and a number. This is you're summing up a number of bugs. So you got to figure out what the loop's going to be, and it tells you to use a for loop. And you're going to see how simple it is with a for loop compared to a do-while loop. It saves you a couple of extra steps. When you get done with that, you zip up the lab sheet and chapter 5 lab 2 program into a compressed zip folder called your last name CH52. Submit that on Blackboard. If you have any questions, email me, text me, or call me. My cell phone number is 706-346-4175. If I don't answer it, leave a message. I'll call you back as soon as I see it. I hope this video helped.